Okay, so since we are done with the facial recognition part, so now we will proceed to the second project, which is actually the symbol recognition and the shape detections. So for symbol recognition, I've chosen the methodology to use template matching, and this is one of the best method I can find online, and it actually worked perfectly, especially with the symbols in the Moodle pages. Alright, so let's just get started. First of all, we just import any library we needed. In this case, only a few libraries are needed, the CB2 and the NumPy. And the fun is actually a function that I declared to add my favorite fun, which is the Hershey complex. So we initiate the program by video capturing it, and also from here, I'm trying to create my own template images, and all the template images are actually made out of images in the Moodle, which is this one. As we can see, it's like these are everything in the slide. So for all of from slide 5 to slide 10, I have chosen to convert the images into grayscale, because the method that I use to match the template is actually cb2.tmccoeff normat. So I have to convert to grayscale so that I can make a good comparison. And then the reason that I've chosen to convert the first 4 slides into color scale is actually because if the conversion for the first 4 images to grayscale will not make a difference between the converted images. For instance, the 4 color images look very alike, and even if I adjust my coefficient to 0.9, they can still detect each other, and this is actually an error, which is not good. So I've chosen to convert them into grayscale, back into color scale, and we will template match it using the color scale. So for the last one, the reason I have chosen to use the function reduce grayscale for is actually because of the oversized template images of the file. So for instance, the original size for, let's just say, slide 5 is actually like this. However, the size for slide 10 is actually very big and much more bigger than slide 5. So by using this function, we can actually reduce the scale of the file, I mean the image, by 4 times of its original size. And then we proceed here to create our own template shape. So for all of these except template 9, we are using a standard template 5 shape, and we declare another template shape specifically for template 9. Also, in this loop, we are creating a frame, yes, to capture the image frame by frame, and we convert the captured image into grayscale. I mean the captured video into grayscale, and we also, at the same time, we keep an original version of the frame. This is actually the resolution, and the function is actually, no, I mean here we are trying to do the template matching function by using the CB2 match template, and this original is actually the image that we wanted. This is actually the image that we captured from the videos. The reason I'm using this because for the first 4, we have to compare, for the first 4 symbols with colors, we have to compare the images using the color scale. That's why the original is actually specifically for the first 4 images with color symbols, and then they are actually compared with their respective template images, and the method I used here is actually the CCOEFF normat method, which is and the working principle is included in my individual report. So for the rest of the symbols, they are all converted into grayscale, and that's it. And then the converted resolution is saved inside a function, or I would prefer to call it a location, where this line here, this function here actually tells you that how similar is your captured videos compared to your template images. So for the color, for the detection for the color symbols, I prefer to use it at a very high rate, because this is actually to increase the accuracy of the template matching method. And for the rest of them, 0.6 is sufficient to distinguish the differences between them. So for every point from here, for any point that lies in the location, the point here is actually means the point in the frame actually. They will actually draw a rectangle around the point, which is the object, and they will include the text, which is actually the name of the template images, on the frame, and everything is repeated, and the steps are repeated for all of the other slides. And then finally we will show the frame out, and then that's it. So we'll proceed to run the code and have a look at the result. Just wait a second, I have to proceed to look for the template images. As you can see, this is the yellow symbol. The orientation and the position of the yellow symbol is quite accurate. You can see the yellow symbol. Alright. So this is a bit more sensitive than the other symbols. And this is actually the red symbol. This is actually the blue symbol. You can see that it's actually detecting it. This is the green symbol. This is a distance symbol, traffic light symbol, scoring goal, ram angle. And for the final one, let's move it closer, and it's the push button symbol.